Okay, so previously we have stopped here for tree diagram. Okay, so tree diagram, right, is basically a way for us to express all our outcomes. Okay, our possible outcomes. So usually the branches at the end, right, you will write out all the possible choices you can have. Okay, so let's say for tree diagram, right? Okay, the first branch, let's say for this example, a bag contains 6 red marbles and 3 green marbles. Okay, meaning you have 2 choices, either red or green. Okay, then 1 marble is drawn at random from the bag. If it is red, it is replaced in the bag. If it is green, it is not replaced. Then a second marble is then drawn. Okay, so in this case, there are 2 events, right? When the first marble is drawn, this will indicate your first chunk over here. Okay, so these are what we call branches. Okay, so for your first branch, meaning your first drawn of marble, right, you're going to have 2 choices, red or green. Okay, so under red, okay, first choice, right, you have 9 marbles in total, correct? Okay. Oh, okay. So under the first choice, right, for you to pick red, you have 6 out of 9 chances. Okay. Then for your green, it is 3 out of 9. Okay, so that's for the first one. Okay, then when you read on, 1 marble is drawn at random, right? If it is red, it is replaced in the back. Okay, so if you draw red, so you're going to go through this branch. Now you're going to look at this branch. That is for the first marble, right? If you draw red, right, then the second marble, you can either draw red or green, correct? Okay, so if you draw red for the first drawn, it is replaced in the back, meaning you will still have 9 marbles in the back, right? Okay, then the possibility of you drawing red again is still 6 over 9 because that color ball is replaced in the back. Okay, so for the second marble over here, it is still 6 over 9 for red. Okay, then for green, over here it is still the same because it is replaced inside, right? It is still 3 over 9. Okay, so that is under the first branch. Okay, then for if you draw green marble in the first draw over here. Okay, then the first chance is 3 over 9, right? Okay, but the condition here is if it is green, it is not replaced. Okay, so the second marble is then drawn at random after this. Okay, so in this case, for your green marble, if it's not replaced, what you are left with is just 8 marbles in the second draw. Okay, then if you draw green in the first draw, that means the second draw you will still have 6 red marbles left inside, right? So this is going to be 6 out of 8. Okay, for the first one. Then for the green one, okay, because the first draw you have drawn 1 green one out already. Okay, so out of 8, you are left with just 2 of them. Okay. Then now, once you complete this diagram, right? Okay, how are you going to use this diagram to help you complete these questions? Okay, so find the probability that the second marble is red. Okay, so you're going to look at the second branches over here. Okay, the second marble is red. It's going to be this one here or this one here, right? Okay, so it means you're going to go this way, or this way, this way. Okay, take note what I said. I said all, right? Okay, so this and this, or this and this. Okay, so the key thing in probability is or you're going to plus. And is multiply. Okay, so in this case, for part B, part 1, if the second marble is red, so it's going to be the probability that the first one is red and the second one is red, or the probability that the first one is green and the second one is green. Okay, so probability that the first one is red is 6 over 9, and then the second one is red is multiply by 6 over 9. Okay, then or the event that the first one is green and the second one is red. So 3 over 9 multiplied by 6 over 8. Okay, then just press this into your calculator. Okay, then you're going to get 25 over 36. Okay, then for part 2. At least one marble is green. Okay, at least one marble is green. It's going to be, okay, let me erase all this. It's going to be either green and green or green and red, right? Or also red and green. Okay, so what do you realize? Only one of the branches are not touched, right? Okay, so there are two ways to do this. So when I want probability that at least one green, this is the same as probability of red and green, or the probability of green and red, or the probability of green and green. Okay, so if I'm going to work out this probability, it's going to be 6/9 times 3/9 plus 3/9 times 6/8 plus 3/9 times 2/8. Okay, so this is going to be 5/9. Okay, versus there's another method. Okay, so the previous time we've talked about complement, right? Okay, so this probability of at least one green, right, is the same as 1 minus probability that none of them are green, meaning both are red. Okay, so the probability of both being red is 6/9 times 6/9. Okay, so this is 1 minus 4/9, which is 5/9. Okay, so you see you get the same answer. Okay, so this is using the fact that your whole probability will add up to 1. Okay, your probability maximum is always just 1. Okay, then okay, I will go through until here for now. Okay, let's do a recap for sets instead. Okay, so these are some concepts. Okay. Okay, so let's go through sets to do a recap first. Okay, so for sets, right? Okay, so these are some of the notations which I will go through already. So this should be quite familiar already. Okay, so over here, okay, there are 3 ways to describe a set. The first way is by listing, which is the more common one. The second way is describing, okay, so basically by a sentence in wordings. Okay, and then the third one is what we call the set builder notation. Okay, so these are just some basic stuff. Okay, over here, these are some things I want to highlight. So again, for sets, right, the elements inside should be distinct. They should be different. Okay, so if they say the set A is the set of all the letters in HAPPY, then it's just going to be HAPNY. Okay, don't repeat the P. And also, when we say the elements in the set, right, the order doesn't matter. Okay, so if I have a set that consists of the elements 1, 2, and 3, this is the same as the set consisting of elements 3, 1, and 2. Okay, so the order doesn't matter for sets. Okay, and also, okay, when we talk about sets, right, you should always include the curly bracket, unless we are just talking about the element itself. Okay, so in this case, if A is the set of all prime or all even prime numbers, there's only one even prime number, right? So you cannot just write A equals to 2. A should be the set including the element 2. Okay, so always write the curly bracket. Okay, now this one. Okay, so we have talked about subset and proper subset before, right? Okay, so just a recap, subset is written in this way. Okay, and proper subset is written in this way. Okay, so subset means all the elements. If I'm going to say A is a subset of B, right? All the elements in A should be in B. Okay, so in this case, elements in A are 1, 2, and 3. So B has 1, 2, and 3 also. Okay. Oh, you need a pencil. You need a pen also. Okay, so in this case, when we say the elements in A are also in B, right? So A is a subset of B. Okay. But okay, now if we talk about proper subset, proper subset has another condition. Okay, it's just not all the elements in A must be in B. B should also have extra elements, meaning B should be strictly bigger than A. Okay, so that's the second condition. Which in this case, you see there's an extra element here, right? 4. So in this case, A is a proper subset of B as well. Okay, so these two are true. Okay, but what if in the question itself, right, you are given a choice to choose between these two? Then always use this one, the proper subset. As long as you know, right, your B is strictly bigger or your A is strictly smaller than your B, use the proper subset one. Okay, so this is kind of like a stricter rule. Okay, this one, this key thing over here. Okay, we never touch much on listing out all the possible subsets of a set, right? Okay, so this one, let me emphasize. The previous time I said the empty set is a subset of all sets. Right? Okay, so if I'm going to ask to list out the subsets of a set. Okay, so first thing, subsets are sets, so they should all include the curly bracket. Okay, these are sets. Okay, so what are the possible subsets of this set? Consisting of the elements 3, 6, and 9. Okay, first, the possible subsets. Okay, your empty set will be a subset of every other set. Okay, so that is your first subset. Okay, the empty set. Okay, the next one. The set consisting of just the element 3 is also a possible subset. Okay, so similarly, the set consisting of just 6 and the set consisting of just 9. Okay, next, you also have the set that is consisting of just 3 and 6. Okay, so this is also a possible subset. And then you also have 3 and 9. And then also 6 and 9. Okay, lastly, there's still one more possible subset. It is the set itself. Okay, the set itself is also a subset of itself. Just recall when we talk about subsets, right? The line below, you can think of it as your linear inequality, as your inequality sign. Okay, so it could mean the set itself is the same. Okay, so the set itself is also a subset of itself. Okay, so in this case, the total number of possible subsets, right? Of A is actually equals to 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 possible subsets in this case. Okay? No, that's not true. It might come up. Okay, so this is just to test the understanding of what subsets are. Okay, and then, okay, just now we talk about sets, you need to put curly bracket, right? Okay, remember this notation, this means number of elements in set A. So number, don't put curly brackets. Just write down the number of elements. Okay, then, okay, over here. A prime, it means all the elements outside of A, right? And then if you prime it again, it means all the elements that are inside. Okay, so A prime prime, it's just like it cancels each other out. Okay, so it becomes A. Okay, then here. Okay, when we talk about union and intersection, union means you're going to include all the elements, but you cannot repeat. Okay, so yes. Again, A union B, whole thing prime. Yeah. Okay, A union B, whole thing prime. A union B means this whole thing, right? This whole chunk. Outside of it means the box outside. No? So it's all the elements outside of it. This part. Yeah. Okay, so always think of the prime as outside. So outside of A union B. Okay, this one you will see later in the behind example. Okay, so now if I'm going to talk about union and intersection in listing form, okay, so if I have two sets, set A and set B, the union of them is basically all the elements that are involved. Okay, but I don't repeat it, because if you see A and B, right, there's this element that is the same. Okay, so when you include them, don't include two twice, because your set should not have repeated elements. Okay. Okay, now intersection. Okay, intersection you only include the common ones. Okay, so we'll pick out all the common ones, which is just two, right? Okay, so your A, okay, there's a typo here, this intersection. So this is N. This is A intersect B. Okay, so the intersection of A and B is just the element 2. Okay, so it's the set consisting of the element 2. Okay, now the shading parts. Okay, when we talk about union for shading, right, whatever you shade, it's going to be considered inside. Okay, so A prime is whatever that's outside of A, right? Okay, so you shade whatever that's outside of A. Okay, union with B. Okay, then now you shade B. This is B, right? Okay, then union means you're going to take whatever that is shaded. So in this case, what you should shade is everything here for union. No, I can cancel. Cannot. Yes. Okay, then it will be like that for union. Okay, then A prime union B prime. Okay, so whatever you shade, A prime is outside of A. Union with B prime outside of B. Okay, so basically what is not shaded is the intersection. Okay, so in this case, it is this. Okay. Okay, now for the bottom part, A union B prime. Okay, this is what you asked, right? Shane, June. So it's outside of, because you already know A union B is these two circles. So outside of it is just, okay, I'm just going to shade outside straight away. Okay, so it's just going to be the outside of A union B. Okay. Okay, now for intersection. Okay, intersection, right? I'm not going to take all the shadings. I'm only going to take the overlapping ones. Okay, so let's say, for example, A prime intersecting with B. So A prime is outside of A, right? A intersecting with B. Okay, then B is just this part over here. Okay, then you're going to take the ones with both the shadings. Okay, which is just this part. Okay. Okay, next, A prime intersecting with B prime. Okay, B prime is outside of B, right? Okay, then A prime is outside of A. Okay, so whatever that is double shaded, right? It is the outside over here. Okay, lastly, A intersect B prime. Okay, A intersect B, right, is the middle part, right? This part over here. Okay, so outside of it is just all the outside. Okay, so I'm just going to directly shade here. Okay, so the outside of your intersection. Okay. Okay, so that is all the summary so far for sets. Okay, then Okay, I've heard that probably. Yeah, we'll go through later. Yeah, just try first. Okay. Change it to all three. Okay, then Sherry, do you have the materials ready with you?
Yes.
Okay, can you try out the WA prep for, you need sets and is it probability?
Yeah.
Sorry?
Yeah.
Okay, so can you try out the WA prep worksheet for sets and probability?
Okay.
Okay. Yeah.
This one, this one
Yes, it goes into focus.
is junior.
Yes, it is. Yeah.
Just this one.
Okay, so you have the elements A is 57. Right? So all of this I need. Number of elements A union right outside is you should only got one. It's just one. A union B is all of this right outside. It's should only plus one. Then the other information we have is this one. Number of elements in A is 37. Number of elements in A is this factor is X, this Y, this X is 6. So all these are there. And then try to solve. Oh, no, no, what they're writing here is the number of elements. Number of elements that are inside the set. Yeah, this is not the elements itself, these are the number of elements in the set. Yeah. Yeah, then diagram is now most elements, not the elements.
This purpose.
The buttons are not true. The thing is for the field is a OSCR, right? Oh, for you to be a true leader, firstly you need to have one pair of parallel sides. Parallel sides means if this is parallel, this plus this plus 300, this plus this plus 300. If yeah,
This plus this plus this.
no, okay, for trapezium, right? The parallel sides this. Okay, this plus this plus 300, or this plus this plus 300. And this one is 100, right? Plus this one, you get 100. No, yeah. It need be a trapezium.
Maybe. This one.
You want to do your forwards too. They also really notice that family is so that's what they're doing. Not only for project of the activity. No way. That means they should not be parallel.
I don't need to
No, your part is correct. It is 103. They say determine if this quadrilateral is easier. So if this plus this doesn't mean this is not a trapezium. Did you remember what is a trapezium?
O S T is this. What is it? I'm not telling you how to choose this.
But what you do it, this one, right? You use one for what? Well, your trapezium is this one, right?
No,
Oh,
that's
that's
not.
take OST, right? Okay, so first, just now you have this figure, right? Then we talk about this in the middle. Okay, but this is in that direction, right? So you're going to look at 0.6. So 5 of this is 260. So this is 206, 360 minus 260. Okay, 154, right? 154 is this one. Yeah. Okay, look at this one's for question A. Okay, then again, this and this. Which one are you trying to find? This one, right? OST. Oh, you mean for part B, huh?
Yeah.
Okay, this can be. Oh, this angle here. Oh, okay, this one, right? Again, this is your radius, right? Radius should be go and like, right? Then you will know this. Just now I thought you pointed to me already the straight line thing. I thought you got that already. Yes, because of the straight line also. Because you can find this two, right? Then straight line can find this one. Sherry, once you're done with your sets, right, can you send me on WhatsApp as PDF? Yeah. You forgot all this. It's fine. Okay, real numbers, right? Is basically all your numbers. Okay, everything, including decimal, negative, fraction, whatever. It's everything. Everything. It's basically just everything. Okay, then natural numbers. Natural numbers are all your positive whole numbers starting from 1. So it's just 1, 2, 3, 4, 5, 6. Yeah, all your positive whole numbers starting from 1. And then whole numbers, you know, right? Whole numbers is including of 0. So 0, 1, 2, 3, 4. And this one's like 1 star. Of course. This means the number of elements in and intersecting W, right? And intersecting W consists of except for 0, right? Okay, so it means the number of elements in the natural number. Right? No, really? You just said this means everything exclusive of 0, right?
Oh, wait, yeah.
So which is just this lah, right? Okay, this one given the outline of the video, find what we got. Yeah, right. Yeah, we got the outline. This is in the okay, so you're going to write down the formula. So how do you find the outline for your this? By R, right? Okay, so you have this equals multiply. Okay, so in this case, okay, here if you divide both sides by 2 times, right, you get rid of this one. So this becomes 1 here. Then this becomes just this over this text. Okay, then here, yeah, starting from here, you divide both sides by this. You're going to have 1. This is 12 over 16, and this is 1. So 1 is just okay. So this becomes 1 equals to 8 double x. Okay, so you go to my so is the okay. So this countries equals to
Because I found this one, there is some place. It's also
Oh, it's just how you flip that one, right? It's the same. Oh, external. You look at that one. Yeah, it's the same. Yeah, correct. Just because that one there's a few outcomes to it. So that is part of it.
and the second one is the external. What's that trying?
Ah, yeah. Correct. Well, now your test is on week 8, then. Exactly. Just week 8. Okay. Your linear inequality is which one? The second one start. Wait. Oh, okay. Okay. Like the very basic one. The cost and data. Okay, yes. Okay, you should draw that one. Your circles, bullshit, very long already. Are you going to stay back soon? Anytime? This Thursday. No. Next Thursday? Next Thursday? Coming up? Is it even open? No. It's Chinese New Year week. Oh, so you're coming this week? Next Thursday? Oh yeah, Thursday. Oh yeah. Okay. Next Thursday. Bring your circle properties. The very long ago worksheet. Oh, and your stats also. The parts that you don't understand. Your data analysis. Just go stuff. The whole thing is it. Wait, the standard deviation is the formula one, right? I don't understand. Oh, you know the difference. You say you don't know how to apply the box and this. You don't know all this. Not everything.
Yeah, like everything.
I try to cover on the week after Chinese. And let's see next Thursday when you come in. Yeah, but next Thursday when you come in, maybe I can cover it first to see which part of business. Okay, bring this huh? Yeah, and the further properties. Then linear inequalities no issue, right? The ones. So which one you don't know? The one is like solving. Yeah, it's solving normal equation. Except if you divide or multiply by negative number, you just split the sign, right? Yeah. That's all. Okay, right. You got equal sign you shade, no equal sign you shade. Yeah, so like that only, huh? Can, right? Okay. So I was wondering why got linear inequalities. Right?
I was always right.
Yeah, I was so shocked. I was like, huh? Are you talking about email? Like, oh, the email. Okay, can. This one is part of this triangle. This one really is second. This one is top is on the triangle. 480 minus this one is. Yeah, let's see what all the angles are called and write it out again. This one. Yeah. Explain why A intercept C is not by C. C is all the perfect squares, right? A intercept C, A is all prime numbers. So if it's not empty, right, that means they are common everywhere. Right? Prime numbers, perfect square. Correct. Okay.
Yeah.
There's a typo. Yeah, this should be equal to empty set. Okay. Okay, wait, this part over here, right? You'll change this to equal to instead of not equals to. Okay, Sherry, also for question 5, right? Part C. A intercept C should be equal to set. Perfect squares. Okay. Explain perfect squares and good vectors. Okay, first we start with 1, right? Okay, so for 1, right? 1 is a perfect square, right? 1 square, but it is not prime. Okay, so that is out of that range. Then all your other factors, right? In your perfect squares, all your other prime numbers will have other factors other than itself. And yeah, and one will just that. So all other perfect squares. No, all the perfect squares will have other factors other than itself, so it is not prime. Okay, so therefore there are limits.
Sure.
Huh?
How
Oh, this other one. Let's see which one you put first. Okay, so you see this? So we then right? From this tangent right to so in this case this is 90 degree. This 90 is 90 degree. Yeah. Then over here, you know, this one. Today we will know this angle, right? This one you found already. You found this, right? So this angle is from this up, right? There, from this up, you also have this angle. So this angle is this angle QR. This is from up Q. Okay, then QST also from up Q. So angle 68, so this one is what? Okay, so that means this angle would be 49, right? Okay, then you know this is 20. 49, 20, then this is 19. Then you can find this one really wrong, right? Okay, so you know this one. You know
This one, this is problematic.
this will be 49, by angles and things.
This one,
Because they come from this same
and
number.
180 minus this one.
Yes, and yeah. So you will know this one, so 19 minutes. Then your try first.
And those are the same segment.
Yeah, the one is angles in the same segment. Then the 90-degree thing is the tangent from external point one.
So what is it? What is it?
For the 90 one,
Yeah.
tangent from external point. You don't really use it. Just right from external EXT can be.
Yeah, from 180 minus the 110 minus 49, just angle in triangle.
Yeah.
This is a
Tangent perpendicular to, this one is this one. This one is like that, the up, that one, this one is just, when it's just one tangent. And then cut through the center here, so it's tangent.
so you know,
This one is what do you do for this? Oh, no, this one is tangent for external. Yeah, tangent perpendicular to radius is just this one tangent. Sherry, you're done with the sets one already, right? You can go on to do the probability one.
Wait, then for this, yes,
Yeah, right. So when we see these two, I got what two tangents meet at a point outside, so it's tangent from external. Got two tangent, then is that one already. One of it only, then is the tangent perpendicular to radius. Okay, right. Okay, O as the angle O as the and let's keep this one, right? This angle plus this angle is near this angle. Okay. This angle O as near this angle. This O plus. Okay, so this angle here first. This angle comes from this, which is right. Alright, I want to say if you look up for radius, right? That's also true. Okay, so you can find those two. Really, right? And then what is the link between these segments? Okay. Yeah, I can see. So always look for the angles around the angle you're trying to find. This one is a quadrilateral one. Wait. You mean this plus this equals symmetric? Oh yeah, correct. It's still under this one. The tangent from external. Yeah, it's one of the reasons. The part B that reason. So you use the same reason. BIOP. It's like you draw down here. Okay, so you want this angle over here. What do you have? This one comes from here. Okay, here. Okay, again, this angle comes from this two, right? These 2 points. This, any other angle? This half. I see any other lines that goes up. Okay. So always there's only a few that you can think of. So every time if it's this kind of angle, you think of angles in opposite segments, same segment.
Unless it seems something.
Yeah, these are in same segment, yeah. Angles in opposite segment, if you see those kind of quadrilateral inside the circle itself and it touches all the points. Yeah, that one then you use the opposite segment. The avoid is actually A, C, D is a quadrilateral. A, C, D is a quadrilateral where A, D is 150. Tell me whether you guys on the circumference. Oh, okay. So in this case, right, A, C, B, D, you want to see whether it lies on the circumference somewhere. This is also called the angles the quadrilateral. So if it lies on the, it means the opposite one is right, which it does, right? So in this case, it does, right? Yeah, this one. The diagram FG and H. Okay, so this one is a dendritic external fluid. You center O and this is if I angle JFG. J is here, right? JFG is this angle over here. Okay, this one. So that's all. Okay, this one. And I think it should come. Okay, this one. Oh yeah, kids. Can you see the results? Yeah. I was waiting for you to see, see whether is there anything useful in this one. Yeah. Okay. Yeah. Okay, what are these ones we have? This is 130. Okay, then you know what is this, right? Straight line. Okay, what else? This one, right, should be 90 degree line. This one of the reasons. Yeah. Okay, and what else? Yeah, right, this would be nice. Okay, then there's another thing, these two, right? This triangle should be the same. Okay.
You can end up with something. But this one.
Okay, yes. Oh, yeah, it's this two. Yeah, this and this, like, I did as these and these and the overseas one, yeah.
Sure.
This one, okay. So again, the Venn diagram shows the number of elements, right? That means this represents the number of elements. Then number of elements in A equals to 27. This means in A, A is so correct. So this, and this add up to 27. The number of elements in A union B prime. In union B prime. A union B is so correct.
Yeah.
Prime is outside. It's correct. So this should be, yeah. Then also for X, your X is all here, except A.
7, 6, 4, minus 5.
Basically this plus this plus this plus this equals 27.
And also,
Yeah. So what you say that? Yeah. This I told you this is 50 degree, right? This one, this is previous, this is right. Correct. So this one should be 50 also. Huh? Yeah, correct. They're getting into that, right? Yeah, correct. Sherry, I sent you your sets marked already. Can you check through your mistakes? Top line three. Your x, okay, this is your set you're going to be, right? So this is the set of elements x such that 3 minus 2x is more than 1. So your x should be not on, right? So you know how to solve this, right?
So 1, 2, 3, 4, 5.
Okay, good. That's all. Okay, this is less than 7, right? So 7 cannot equal. It's not less than 2. Yeah, so 7 cannot equal. And then find the number of elements in this. Okay, A prime, right? A prime means not. Yeah. This is the self-positive integer and x is the set here, right? So it should be 1 all the way to okay. A then not in A, right? So we're going to cancel all this out, right? Then intersect with B. So basically, okay, here again, okay, you can see right, A prime, okay, let's say A prime, this is like A prime is not right. Intersect with B. This is your figure. Yeah, that means what is the intersecting part? This right, the middle part. The middle part is basically the intersection between it.
So it's the numbers 1.
Yeah, 1. Okay, so the number of elements in there is just 1. That's equals to 5.
What is natural?
Okay, natural numbers are all your positive numbers starting from 1. Whole numbers are positive from 1. So 1, 2, 3, 4, 5, 6, 7, 8. Your numbers are everything, decimal, rational, irrational, all the negative, all. Whole numbers include 0, so 0, 1, 2, 3, 4.
The natural numbers is not everything above 1.
Yeah, including what? 1, 2, 3, 4, 5. Positive integers starting from 1.
Whole numbers is
Whole
under.
number includes 0, right? Yeah. Which one is 0? If you talk about natural numbers and whole numbers, right? This has more independent, right? Because got one more 0. So is these most of them please call this the most of them. So this is not true.
But then this true.
It's negative 2 as kind of the non-true.
It's
Okay, again, whole numbers.
not
No negative 1. So it's actually. Okay, and then the number of elements and intersect them. Okay. The intersection of these two are. Huh? Yeah, everything above 1, right? And everything above 1 is the same as just. Okay, obtuse angle QOS. QOS. Here again, QOS, right? Obtuse nature. Yellow side is reflex. Okay, obtuse angles are angles that are more than 90, less than 180. Right? So it's this side one. What is the one? Okay, first this side. This angle is in where? Where is this? Center, right? Okay, so when you think of this center, there's a more. Huh? Yeah. This one you don't have it, right? Maybe what you QPS equals to whatever they did here. Okay, then. Something. This is 90 here. That is the tangent for is the 1.1. So all the from the center here. The center here cuts through the tangent this side. There was it's
this one shading the
Venn diagram shape. A intercept B is something, right? No. Okay, A intercept B is just nothing, right? Union with B prime, basically, you are just going to shape, right? So outside of you put this up. Yeah, so you can shape this. You know that. Okay. Oh, yeah, okay, never mind. This is straight over different. This one remember, and then say the angle should have for tangents from external. Yeah, sure. No, it's here. And this one, AOB, right? For tangent from external point. This angle and this angle at 180. Yeah, it's a result of this tangent from external point. So straight away can try reading the first one. Because you're given this. Yeah. Tangent from external. Yeah, but I want to do something. A prime intercept B, you're going to find a number that doesn't have this kind of this thing, right? This is our first part, A prime is outside of this few numbers, right? So in this case, 1, 4, 6, 12. So A prime has no lah. Intersection doesn't necessarily be cancelled, right? Okay, so this is for so this is your A prime, right? Then your B is this, right? Intersection means the ones with common. This one and this one. Yeah, are you sure it's already? This one inequality, yeah. Yeah, I thought you think inequality okay. No, it's not. Except one. Okay. So inequality is a solving equation that I should this over, right? So basically that I should this over -1 to x, right? Then to solve for x, I divide by 2. This is sorted, right? Divide by 2 is 7. This basically means x is less than 7, right? X less than 7, we got all this. I told you less than 7, right? I told you, yeah. If you see what are repeating terms only got 1, right? This one, that's right. The intersection between A prime and B is just one number, which is 5. So therefore, the number of elements in A prime and B is 1. That's so funny, yeah. A union B union C, right? It's all this, right? Outside of it is this part. This part is not the whole universe, it's just this outside part. So the most appropriate way to describe this is it's not empty.
It's not empty.
It is empty. It is empty because there's nothing outside there. Right?
Um,
Yeah. Okay. So this should be empty. Not the universal set. The universal set includes all of this. Very true.
Yeah, that's
This one. Okay. Okay. Union means whatever you shade. Correct. Okay. So first A is this part. First, union B. Okay. This part. Union B. B part is all outside.
Yeah.
Okay. So it means put this time. So that's what union. Union means whatever is shaded, you include it. Then intersection, then you only include the overlap. Next week.
I think.
Okay, then Sherry, wait. Okay, then Sherry, for your probability, right? Once you're done, can you send it over to me on WhatsApp that I mark for you? Can? Sorry?
Sorry.
Huh? Oh, you've sent it over already, is it?
Yeah.
Okay. Okay, I'll mark it and send it back to you. Can?
Okay.
Okay. Okay, that's all. Okay, I will mark it with annotations, then send it over to you on WhatsApp. Okay, Ken?
Okay.
Okay. Bye.
Bye.